last lesson of RF6 and 7. We're going to be looking at some linear equations in context. So some word problems, some applications of these linear equations. How can we make a linear equation out of some real life situations? So starting off, we have our first question here. To join a local gym, Kareem pays a startup fee of $99 plus a monthly fee of $29. Right, so some key information there. We have a couple of values. Right, thinking of this logically. So you're paying a startup fee. You're probably only going to pay that once. Okay, pay once. And then you're going to pay a monthly fee of $29. That's a recurring. Right, fee. That's how much our cost is going to grow by each month. Write an equation for the total cost C dollars for n months at the gym. Right? So n is going to be our independent variable, right? The cost of your membership depends on how many months you spend at the gym. So, right, we have our usual equation, y equals mx plus b. Right, that's our general go-to, not general form, but that's our slope-intercept form. It tells us a couple of things, right? We have our y-intercept. Remember, we talked about how that usually represents an initial amount. Our slope, right, this is our growth. This is our rate of change. Right? And then y and x, y is our result, really. Right. So in this case, y, that's going to be our cost, right? The result of all of this is how much money does your gym membership cost? And that's equal to, right, the rate of change, that's going to be my monthly fee. That's going to look like 29n, right? Because what that means is for every month, my cost is going to increase by 29, right? When n is 1, 29 times 1. Right? When n is 2, now I've paid for 2 times $29 monthly fees. But there was that initial fee at the start, right? Plus, that $99 gets tacked on to the end. Right? It's always going to be 29 times the number of months. So again, for 1 month, 29 times 1, you pay that $29 once, plus that $99 that you paid right at the start. And this is talking about your total cost, right? From the beginning of when you went to this gym, there's your total cost. There's your equation. Suppose Kareem went to the gym for 23 months. So again, identifying what is that variable telling us? Is it C or N? Right? We only have 2 options. Because it's N, where they told us it was N months, right? N is going to be 23. What was the total cost? Okay, they're asking us to find C. So I'm going to leave C where it is, right? That's my unknown. But I'm going to using that equation plug in N. So 29 times 23 plus 99. I'm going to go through, I'm going to calculate this. I'm making sure I'm following my order of operations. I'm going to do 29 times 23 first. And that's going to give me $667. Right, so for almost 2 years of going to the gym, you're paying $667 total dollars in membership fees. Plus, you have to include that startup fee because 23 months ago, you paid an extra $99. So you want to make sure that's included in the cost. So at the end of the day, you've paid $766 towards your gym membership, or Kareem has paid that. So let's write that. Kareem paid $766 for 23 months of membership. There you go. There's your nice, succinct answer. Right? We asked you a question. We gave you an answer. suppose the total cost, looking at the next one now, suppose the total cost was $505. So again, now identifying what variable is this talking about. Does this tell us anything about the number of months? No, so this isn't going to be the value for n. Right? This tells us that the cost, the C, is going to be 505. And then it asks us, for how many months, right? That's what we're trying to find out. We don't know n. So we're going to go ahead and substituting in 505 for where my C is now, right? The left side of the equation. 29, I'm leaving n, right? It's still $29 a month. The equation hasn't changed, but the number of months has, and we're trying to figure out what it's changed to. So I'm going to get n by itself, right? I'm trying to find n. I want to isolate that. So piece by piece, I'm going to remove the things that are attached to n, working through bedmass in the opposite order, right? I'm going to peel that 99 away by subtracting it from both sides. I get a 406 on the left side, and I just have 29n left on the right side. Now to get n by itself, to get rid of that 29, I'm going to do the opposite. It's multiplied to n. I'm going to divide. And then when I do that, when I do 406, divided by 29, I get 14. And on the right side, I'm just left with n. Right, so what does that mean? What does 14 equals n tell us? Well, it tells us that 14 months costs $505. Right, essentially, if we look back at our steps, we're paying $406 worth of monthly membership fees and that $99 for that initial fee. Right? And that tells us that 14 months gets us up to that price. Could the total cost be exactly $600? Justify your answer. Right? Essentially, this is kind of asking us, is this data continuous or not? Well, let's see. Let's do the same thing we just did. Let's say our cost is 600. I'm going to figure out how many months that is. So, getting the n by itself, same step. Right, what you're doing here is you're saying, well, right, and this is math you've probably done in your head before. Well, I paid $600. I know 99 of that was the startup fee. So when I subtract 99, I know that $501 of that must have been those $29 a month fees. If I break it up into those $29 a month fees, I'm talking about how many months I've paid that for. Right? 29 times what? 29 times the number of months gave me that 501. And when I do that math, 501 divided by 29, it tells me I get 17.276, we'll round that, is n. Does that make sense? Right, does it make sense that you've been to the gym for 17 months and then do they just charge you like a cent every day? What is their process like? No, they probably charge you once a month. So because n is not a whole number, right, it doesn't make sense for your gym to charge you for a quarter of a month, right? They're going to charge you for the whole month or they're not going to charge you at all. So n has to be a whole number, right? It can't be an integer either. The gym is not going to start paying you to stay away from the gym. So it's actually not possible to spend $600 exactly on this specific gym membership. Right? N has to be a whole number. The number of months that you attend the gym for, that you pay for at the gym, has to be a whole number. So looking at another example, for a service call, an electrician charges an $80 initial fee. So again, that's kind of helping us look at that idea. And I'm talking about my rate of change plus any initial values. My y-intercept, right, the start, is usually my initial value. So I have that initial fee. I know that's going to talk about my B value. Plus $50 for each hour, right? With X is hours. And if I do 50 times X, 50 times the number of hours I'm working, that's telling me my rate of change. That's telling me how much the cost is increasing for every time I bump up X by 1. And again, cost is my final result. Right? That's a lot of the time the final result. So here, my cost is equal to 50, I'm going to call this T, right? They told us for T hours of work, right? Because if I do 50 times 1 hour of work, I pay $50. 50 times 2 hours of work, I'm paying $100, right? That's how wages work. But there was that initial fee. Regardless of how many hours you work, there's still an $80 service charge, right? An $80 I drove out to your house to figure out the problem sort of idea. So this is our linear equation, right? Slope-intercept form tells us our rate of change and tells us our initial amount. So looking at the word problems, how would the equation change, right? What would we do to this if they charge a $100 initial fee plus $40 for each hour she works? Well, our rate of change would be less, right? It would grow less quickly. Right? For every hour you work, it's actually $10 less. And so after 2 hours, it's $20. 3 hours, it's $30. But there's a higher initial fee. Right? So this one, when we think about this, so this electrician costs more. At the start. Right? If you get 1 hour of work from this first electrician, so you have 1 hour of work, so you spend $50 for that hour of work, plus $80 for the total cost, or for the initial cost, you're paying $130. If, for the second electrician, you get 1 hour of work, right, you're doing 40 plus 100, you're paying $140. So it seems like this electrician costs more. But when we start to look at that more, what happens after a second hour of work? Well, the first electrician costs us $100 worth of hourly wages plus still that 80 initial amount. And then our second electrician costs $80 worth of hourly work, but it was still $100 to start, so they actually cost the same amount for 2 hours of work. So part C, we're going to keep going there. We're going to create a graph representing the first 4 hours that she works, right? Either based on the first cost or based on the second cost. Let's see. Let's compare these two. So I'm going to do them in 2 separate colors so that we know. And I'm going to write this as a function, right? We're going to quickly go back to that idea of function notation. The cost of T hours of work is 50 times T plus 80. And then on the right side, I'm going to do the other equation. The cost of T hours of work is 40T plus 100. Right, putting in that function notation just so we can a little quicker talk about the idea that I'm saying the cost of 1 hour, the cost of 2 hours, the cost of 3 hours, and the cost of 4 hours for each different wage that we're looking at. Right, and again, this is still just telling us that Y value. It's still just telling us the cost, but we're recognizing it as a function. Right, every time that I put in is going to give me a unique cost. So 1 hour, we already said for the first electrician was $130. For the second hour was $180. For the third hour, all right, we're going to do 50. Let's write that down. We're going to do 50 times 3 plus 80. So $150 plus 80 more dollars is going to be $230. And then the cost for 4 hours is going to be $280. Looking at the earlier or more expensive initial cost, but cheaper per hour cost, we started at $140 more expensive. We tied out at $180 after 2 hours. After 3 hours, 40 times 3 plus 100, oops, gives us $220. And the cost for 4 hours, so 40 times 4, it's going to give us $260. So let's graph this. All right, let's give our graph a nice title. Cost of electrician. Our Y value is our cost in not hours, in dollars. And our x-axis, or our independent axis, is going to be time, and that is in hours. So I'm just going to divvy up along the bottom, get myself some nice values to start with. I'm going to go 1 hour, 2 hours, 3 hours, and 4 hours, right? Make a nice even scale that uses up a good amount of the graph. And now we need our Y values to range between 130 looks like our lowest over here. 280 looks like our highest. And so we kind of want to split that up. We have 2, 4, 6, 8, 10, 12, 14 blocks. We want to go up to about 300. I'm going to make every 4 blocks be 100. 100, 200, 300. That'll give us a pretty good representation. So each square has a scale of 25 here. All right, so let's plot those graphs, starting with our first equation in blue here. After 1 hour, I'm at 130, so slightly above 125. After 2 hours, I'm at 180, so slightly above 175. After 3 hours, I'm at 230. And after 4 hours, I'm at 280. All right, a nice straight line again, because we see it has a constant rate of change. It should be a straight line. Looking at our red graph, the first one I'm at 140, so I'm a little bit higher up, a little more expensive. Then after 2 hours, I tie for 180. After 3 hours, I'm at 225. And after 4 hours, I'm at 260. So again, makes a straight line, but doesn't actually rise quite as quick, right? Our slope is less so for the second graph. So we want to quickly look at this graph, remind ourselves that this data is discrete. And because an electrician is probably not going to charge you for 1 3/4 hours, they'll probably either charge you for 1 hour or charge you for 2. We don't want to connect these lines. And so that can help us see, right, visualize how, if you're, right, what does this data tell us? Which one's going to be more beneficial? Well, if you think you have hours and hours worth of work, oops, you're probably going to want to hire the second electrician, because in the long run, the longer you hire them for, the cheaper they end up being. But if you just need an hour or even 2 of work, then the first electrician is probably your better bet. Looking at the next word problem, the speed of sound in air is a linear function, right? Again, that's good to know. We're always talking about linear functions here, of the air temperature, right? So it's sound versus temperature is our x and our y's. When the air temperature is 10 degrees, the speed of sound is 337 meters per second. When the air temperature is 30 degrees, the speed of sound is 349 meters per second. So what they're telling us here is actually just a couple of coordinates, a couple of points. And if I say that everything here, my x values are degrees Celsius, my y values are my speed, right? Then I have a relation, right? X is related to y. The temperature is related to the speed. So we have a couple of points here. The first point has a degree or a temperature of 10 and a speed of 337. My second point has a temperature of 30 and a speed of 349. And as the temperature increases, it looks like the speed is increasing. So these 2 points, I'm going to call this x1 and y1. I'm going to call this x2 and y2. And I'm going to use my regular slope formula. Remember, y2 minus y1 over x2 minus x1, which really is just point slope form. So my slope, 349 minus 337, right? What is my change in y's? What is my change in speed? In relation to my change in temperature, right? Change in x's, change in my independent variable. So I do 349 minus 337, I get 12 over 20, which I'm going to reduce that fraction by 4, top and bottom. Right, that's our greatest common factor between 12 and 20. And I'm going to get a 3/5 as my slope. So writing that in my point slope form now, I'm going to go y minus, and I can choose either of these points that I have. Let's just go with the one labeled x1 and y1. Y minus 337 is equal to 3/5 of x minus 10. So there's our equation in point slope form. We had a point. I could have used the point 2 as well. And I have my slope that we calculated using the fact that they gave us 2 points, right? We can always find the slope when we're given 2 points. Use this equation now to determine the speed of sound when the air temperature is 0 degrees. So now they're telling us that x, oops, try that again, x is 0. So we plug that right in. Y minus 337 is 3/5 of 0 minus 10. Right? Trying to find y, trying to solve for that speed, that y value. So add mass, and I'm going to deal with the brackets first. In this case, inside the brackets, I can do 0 minus 10. Y minus 337 is 3/5 of negative 10. Now I'm going to multiply y minus 337. Okay, 3 times negative 10 divided by 5. What that looks like, right, is negative 30 over 5, which gives me a negative 6. And the last thing, I want to get y by itself. I'm going to bring that 337 to the other side. And I'm going to find out that when I have a temperature of 0 degrees, I have a speed of 331 meters per second. Okay? So when x is 0 degrees Celsius. Y is 331 meters per second. All right, we have a coordinate of 0, 331 in terms of this graph. All right, double check, look at your answer. Does that make sense? Well, if at 10 degrees it was 337 meters per second, and 30 degrees it was 349, it would make sense, right, that at 0 degrees that's the slowest value we have so far, but it's not too far different. All right, one last example here. Peanuts cost $2 per 100 grams, and raisins cost $1 per 100 grams. Charles has $10 to purchase both of these items. So let's generate some data for this relation. Right, let's just think of some ordered pairs. So let's go peanuts. And we'll go raisins. Raisins should probably be in purple, because it's a very important fact that grapes are purple. All right, so peanuts cost $2 per 100 grams. So if we're talking about, right, the grams, and then the cost, if I buy 100 grams, it's going to cost me $2. If I buy 200 grams, it's going to cost me $4. If I buy 150 grams, assuming that we can buy them in half, right, in 1 gram increments, right, that's going to cost me $3. Because we know that for every increase, right, of 100 grams, we're going to see an increase of $2. Raisins, on the other hand, if I buy 100 grams of raisins, it costs me $1. What a cheap snack. If I buy 200 grams of raisins, it's going to cost me $2. We can assume that if I buy 150 grams of raisins, it's going to cost me $1.50. So I've generated some data. We want to graph the data now. So let's make some room for debate. So on our graph, right, independent variable, let's say these are our grams. Let's say this is our cost. Okay, this is dollars. This is our weight in grams. And let's go ahead and let's say 100 grams, 200, 300, 400. All right, let's go up to 500 grams. And then let's find our cost. All right, well, let's quickly say for peanuts, if I start to graph these, right, 100 grams of peanuts is $2. 200 grams, we said, was $4. 300 grams, right, we can calculate is going to be $6. Raisins, on the other hand, 100 grams was $1. 200 grams was $2. 300 grams would be $3. Before we finish this, let's move to part C. Let's write an equation for the relations. So over here, peanuts, we know, right, that the cost of peanuts, we know from our chart, right, that our peanuts have an increase of $2, so our Y value increases $2 for every 100 gram increase. So our slope here is $2 over 100 grams, right? Or it's 2 over 100. times, let's call that W for weight, right? So, and there's no initial cost, right? It doesn't cost you $3 to say, well, I think I might buy peanuts today. It's free until you buy any peanuts. So our equation is going to look like 2 over 100, right? Or let's call that 0.02 times weight, right? Because it's essentially going to be 2 cents per gram. So if I input there into W, how many grams I'm buying, it's going to tell me the cost. If I move over to raisins, it's the same idea, but it looks like for $1 for every 100 grams. And again, no initial cost here. It looks like for raisins, oops, it's going to be 1 cent, 0.01 times W. Right? They have different rates of change. They have different growths. The cost of peanuts is going to go up quicker than the cost of raisins. So we have some equations there. Let's go back. What is the next thing they want from us? Will Charles spend exactly $10 if he buys 300 grams of peanuts and 400 grams of raisins? Well, let's see. If for peanuts, we know it's 2 cents times the weight. So the cost of those peanuts is going to be $6. Right? 2 cents times 300 gives us 6. And then for the raisins, 0.01 times, not 300, we're buying 400 grams of raisins. And that cost is going to be $4. So what is our total? Yeah, right? The total is $10 on the nose. Will Charles spend exactly $10 if he buys 400 grams of peanuts and 300 grams of raisins? Well, let's give that one a try. The cost of 400 grams of peanuts, I'm doing 400 times 0.02, and that's going to end up giving me 8. So he's buying $8 so far worth of peanuts. If he buys 300 grams worth of raisins, that's actually going to end up costing us $3. And so here our total equals $11. So no, he will not spend $10. What are the domain and range of this linear equation, of this linear relation? Okay, let's do each of them. So the domain of buying peanuts, right? Thinking about our domain, talking about our weight, right? That's what we're buying. The least I can buy is 0 grams. I can choose not to buy any peanuts. And then the most I can buy, right? If I only have $10 to spend, is it looks like the most I can buy is 500 grams. Right? So if I'm buying 500 grams at a cost of $2 a gram, that's going to max me out at $10. I can't go past that weight, or else I can't afford it. On the other hand, the domain of raisins, again, I can choose to buy no raisins at all. And I can max out buying 1,000 grams or buying a kilogram of raisins, because they're only 1 cent per 100 grams. Well, does this mean I can find both? No, I cannot necessarily buy 500 grams of peanuts and 1,000 grams of raisins. That's just the maximum value that each of them have possible, separate from one another. Our range, again, I can pay $0 because I don't have to buy any peanuts. I can also max out at $10 because I only have $10. And then for raisins, our range is going to look the same. Right? I can buy $0 worth of raisins. I can also buy $10 worth of raisins. So looking at our graph, right, I'm going to include a point for both of these at 0, 0 when I choose not to buy either. Right, $1, $2, $3, $4. Right, peanuts at $4, we said, or sorry, 400 grams was $8. 500 grams was $10. The highest this graph will go is up to a 10. Raisins, on the other hand, are going to keep going up. Okay, 200 grams, 300 grams, 400 grams, 500 grams. They're going to keep going up until we hit 1,000 grams. And in this case, these lines are continuous because I can choose to buy any weight in between there that I want. And I can choose to buy any weight of peanuts that I want. I could buy 450 grams. However, it is going to stop, and I should have adjusted my graph for this better. This is going to stop at 1,000 grams and $10 for raisins. And it does stop at 500 grams, $10 for peanuts. And so that's the last problem we have for RF6 and 7. Hopefully these videos helped you out, made a little sense to you. If not, please ask questions. Again, there's lots of practice links at the top here throughout the whole booklet. If you need some extra practice, go back through, say, hey, I didn't understand the word problems. Here you go, here's some more word problems. All of these are in chapter 6 of our textbook. If you have any questions, shoot me an email, and check it in your tutorials, pop in during focus, and I will see you all in our next unit.